Hello, precious one. I welcome you into Kenyako Mathematics Classroom. On this platform, I'll be teaching elective mathematics and core mathematics. But on this particular episode, we are looking at matrices and linear transformations. Now, we'll be looking at linear transformations in general. If you have been following my videos on matrices, we have come very far. And so I advise that if today is the first time you are watching me on Kenyako Mathematics Classroom, then you can subscribe to the channel so that anytime you release a video, you will get a chance to watch our videos or our presentations. Now, today we are going to look at linear transformations. We are going to look at linear transformations, and the linear transformations we are going to explain with respect to matrices. Linear transformations. We are going to explain the linear transformations with respect to matrices. Now, when we consider if we have the matrix, let's say we have A, B, C, D. Now we know this is a 2 by 2 matrix, and I guess by now you know why this is a 2 by 2 matrix if you have been following our video so far. Now we have 2 rows and we have 2 columns, and so this is a 2 by 2 matrix. Now, how do we get the linear transformation out of this? That's the most important thing we want to look at. Now, to deduce your linear transformation from this matrix, we say that A of xy maps to, we have A, B, C, D of xy. Now we have A of xy mapping to, this is a 2 by 2, and this is now a column matrix. You can see that. And so how do we multiply the matrix by a column matrix? We multiply A by x, then we have plus B times y, then we have C times x, C times x, then we have D times y, so D times y. Now to simplify this, we have A of xy, this maps to A times x is ax, and B times y is by, then we have C times x, cx, plus D times y is dy. So our A of xy will now be, so we have ax plus dy, okay, then we have cx plus dy. So we can simplify this as A is to x, y, this maps to our first row. The first row we have ax plus by, then the second row we have cx plus dy. So this is the linear transformation. So the linear transformation can either be written of this form, in this form, or this form. And so this is the linear transformation of this matrix A equals A, B, C, D. So in general, that is how you write the linear transformation out of a given matrix. Now later I will explain linear transformations in general, but I'm now explaining linear transformations with respect to matrices, because you have been looking at matrices and linear transformations in general. So if you are given the 2 by 2 matrix A equals A, B, C, D, and trying to get your linear transformation from the matrix, that is what you see. So we have A of xy, and that maps to A, B, C, D. That's the matrix you are given. Now we have xy. So A of xy maps to, we now multiply the matrix by the column matrix. So we have A times x plus B times y. And we are done with the top. Then we have C times x plus D times y. Now when we simplify, A times x is ax plus B times y is dy. C times x will be cx plus D times y is dy. And that's the same thing we have here. So we can write, this is the linear transformation of this particular matrix. Either in this form, it can also be written in this form. So when you are given the linear transformation, you should be able to also write your matrix back. And if you are given the matrix, you should be able to write your linear transformation. And so on this particular episode, I'm teaching you how you can get your linear transformation out of a given matrix. And we also look at how you can get your matrix out of a given linear transformation. Now let's proceed. Let's assume that you are given the matrix A equals, you have 1, 2, you have 4, 3. You are asked to write your linear transformation or try to deduce your linear transformation from this particular matrix. So we have we have xy, this maps to, our matrix is 1, 2, 4, 3. Then we introduce our xy. Now we have A of xy, and this maps to, we now multiply the 2 by 2 matrix by the column matrix. Now we have 1 times x plus 2 times y, then 4 times x plus 3 times y. So we have 1 times x plus, we have 2 times y. Then we have 4 times x plus 3 times y. So we have 3 times y. Now A of xy, when we simplify this, we have x, that's 1 times x is x, plus 2 times y is 2y over there. Then 4 times x is 4x, plus 3 times y is 3y. So we can write that A of x comma y, this maps to, we have x plus 2y comma, we have 4x plus 3y. So this will be the linear transformation. This will be the linear transformation of this particular matrix A equals 1, 2, 4, 3. 1, 2, 4, 3. So in general, that is how we deduce our linear transformation when you are given a matrix. We will be looking at how to also write a matrix when you are given the linear transformation. So in general, take note that A of xy maps to x plus 2y. That's the first row. Then 4x plus 3y. That's the second row. Now, if you are writing the linear transformation in this form, take note that the comma separates the first row from the second row. Take note, it's very important. If you are writing the linear transformation in this form, the comma separates the first row from the second row. So the first row is x plus 2y, then comma we have 4x plus 3y. So the comma separates the first row from the second row. Now let's continue. Now we continue. We are going to take a look at an example. Let's assume we are also given the matrix. We are given matrix B to be equal to, let's say we have 4, 2, then we have 0, 3. This is the matrix. And let's assume that we are asked to find or deduce our linear transformation from this particular matrix. Don't forget, in doing that, we have B of xy, and this one maps to, our matrix is 4, 2, 0, 3. Now we also introduce our xy. So B of xy, this will map to, we multiply the matrix by the column matrix xy. So we have 4 times x plus 2 times y. We have 0 times x plus 3 times 3y. So 4 times x, we have 4x plus 2 times y is 2y. 0 times x, we have 0. And so we have 0 plus 3 times y, we have 3y. Now to simplify this further, we are going to have 4x plus 2y, that is 4x plus 2y. Then 0 plus 3y will be 3y. So our B of x, y will map to this one. We have 4x plus 2y. Then we have 3y. We have 3y. And so B of xy maps to 4x plus 2y, then 3y. And so in general, that is how we find the linear transformation when you are given a particular matrix. That is how we find the linear transformation when you are given a particular matrix. We are also going to look at how best we can deduce our matrix when you are also given the linear transformation. And so let's take a look at a question and see how best we can solve the problem. Let's take a look at a question and see how best we can solve a problem. Okay, so Now we are looking at how best we can also write a matrix when we are given a linear transformation. Now let's assume that we are given the following linear transformations. We are given the following linear transformations. The first one is A is to x, y, and this maps to, we have 2x plus 3y, comma, then we have minus 2x plus y. The second one, we have B is to x, y, and this maps to, we have minus 2x, comma, then we have 2x plus 3y. Then we have the third one, we have D is to xy, and this maps to minus x, then we have y. And let's assume that you're also giving P of xy, and this maps to, we have 3x minus y, then we have 7y. Okay, so assuming that we are given this linear transformation and we are asked to write down the matrices, we are asked to write down the matrices of the following, the matrices of the given linear transformation. So now let's take a look at how best we can solve the problem. So we have the first one, A of xy maps to 2x plus 3y, comma, minus 2x plus y. I told you that the comma separate the first row from the second row. So given the first one, we have A of xy, this maps to, we have 2x plus 3y, then we have minus 2x plus y. Minus 2x plus y. So now when you look at this, this can also be written as A of xy, and this maps to 2x plus 3y will be the first row, will be in the first row, then minus 2x plus y will also be in the second row. And so this can also be expressed as A of xy, and this maps to, now you realize that the coefficient of the x term here is 2, that of the y term here is 3, that of the x term here is minus 2, and that of the y term here is 1. And so this can be written as the coefficient, we have 2 here, then we have 3 here, we have minus 2, then we have 1. When we multiply this by xy, we are getting back what we have here. And so we can see that the matrix A is 2, 3, we have minus 2, and 1. So this is the matrix of this particular linear transformation. I guess by now you understand what is really happening. So if you're also given the linear transformations, this is how you deduce your matrix out of the linear transformation. Don't forget, it's A of xy maps to 2x plus 3y minus 2x plus y. So A of xy maps to 2x plus 3y. I told you that the comma separate the first row from the second row. So we have 2x plus 3y up there, then we have minus 2x plus y also down here. Now, when you look at the coefficient of the variables, we have that of the x here, we have 2, y here, we have 3, x here, we have minus 2, and the y here, we have 1. We don't write 1 y. That is why there is no 1 there. But the coefficient of the y here is 1. And so the coefficient, you have 2, 3, minus 2, 1. So 2, 3, minus 2, 1. And because it's in terms of x and y, we have the xy. Because when we multiply these by the xy, you are getting back what you have up there. If you multiply 2, 3 minus 2, 1 by xy, definitely you will get this back again. You can try that and see, because you know how to multiply a 2 by 2 matrix by a column matrix. So if you multiply this by this, you are getting this back. And I advise you to try that so that you can understand what you are doing. And so you are left with 2, 3 minus 2, 1, and that is the matrix A we are talking about. So that is how best we solve that particular question, the first one. Now let's look at the second question. We take a look at the second question to see how best we can solve for that. Now the second question, the transformation is B of xy. This maps to, we have minus 2x, comma, we have 2x plus 3y, and we are asked to find or deduce the matrix, write down the matrix B out of this linear transformation. So we know that our B of xy, this maps to that's the linear transformation, this maps to, I told you that the comma separate the first row from the second row. So before the comma we have minus 2x. Before the comma we have minus 2x, and after the comma we have 2x plus 3y. 2x plus 3y. And so if this is what we are given, take note that when you look at the first row, we have minus 2x plus, there is no y term. There is no y term. But it's supposed to be plus 0y, but 0 times y will also give us 0, and that's why it's minus 2x up there. And if you are trying to explain or to simplify, this will give us, don't forget that the coefficient of the x term here is minus 2. So you are going to have minus 2. But because there is no y term here, then you are getting 0. Coefficient of the x term here is 2. The coefficient of the y term here is 3. And this will be multiplied by your xy. This will be multiplied by your xy. And so you can now write that the matrix B equals minus 2, 0. Then we have 2, 3. This is the matrix B. Now when you multiply minus 2, 0, 2, 3 by xy, you are still getting back. You can try that and see. You will still get back this. And so it's very important. Please take note. I told you that when you are given the linear transformation, the comma separate the first row from the second row. And so if you are trying to get your matrix out of it, you have B of xy, this maps to the minus 2x will be the first row expression. Then the 2x plus 3y, 2x plus 3y will be the second row expression. And so B of xy maps to, now the coefficient of the x term is minus 2, you have minus 2 here, but there is no y term here. That means that the coefficient is 0. That's why there is no y term there. Take note, that one is very important. Then the coefficient of the x term here is 2. That of the y term here is 3. Multiplied by xy. So if you want to find the matrix, your matrix is not in terms of x. So the matrix will be the matrix you get here. So it's minus 2, 0, 2, and 3. And so that is how we write the matrix. Now let's see how best we can also solve for the third question. Question number 3. We have D of xy. And this maps to, we have minus x, then we have y. And so we have D of xy, then this maps to, we have minus x, then we have y. But I told you that the comma separates the first row from the second row. So now when you get experience in this, as soon as you see the linear transformation, you can write down the matrix. When you get experience in this, you can write down the matrix. But this one, you can see that now I told the comma separate the first row from the second row. So before the comma, we have only minus x. So the coefficient of the x term is minus 1. But there is no y term there, so that constant will be 0. Then after the comma, we also have y. There is no x term there, so the x value will be 0. But because there is y, the coefficient is 1. So you can deduce the matrix if you get experience in what you are doing. Now we have D of xy, and this maps to, don't forget, when you look at the first row, the coefficient of the x term is minus 1, but there is no y term up there, so we have 0. Now when we look at the second row, you also see that there is no x term, and so we are going to have 0, but the coefficient of the y term is 1. And so this will be multiplied by xy. Now the matrix D will now be minus 1, 0, 0, 1. This will be the matrix. So that is how we write the matrix out of this linear transformation we are also given. Now we are going to consider the last one. That is P of xy. That maps to 3x minus y, then 7y. And I guess this one, you can even write the matrix. The comma separate the first row from the second row. So the matrix P will be 3 minus 1, 0, 7. And I know, I guess you understand why it's 0, 7, because there is no x term after the comma. And so the coefficient is 0. That's why there is no x term. because 0 times the x will give us 0. So it's 3 minus 1, 0, 7. That will be the matrix P. But now let's try to solve it so that you can understand what we are doing better. Now, the linear transformation P is xy. This maps to, we have 3x minus y, then we have 7y. So we have P of xy, and this maps to, we have 3x minus y. That's the first row. Then we have 7y. Now, to further simplify this, we have we know that the coefficient of the x term here is 3. That of the y term here is minus 1. But there is no x term here, so we have 0. And the coefficient of the y term here is 7. This is being multiplied by this. Take note, once again, when you multiply 3 minus 1, 0, 7 by xy, you will still get back this expression. And so the matrix P will be equal to 3 minus 1, 0, 7. 3 minus 1, 0, 7. And so that is how we also deduce the matrix out of the linear transformation. Now, we are going to look at something, and I want you to take note of what I'm going to explain to you. When you have a matrix and you multiply the matrix by the point, you are getting the image. Take note of this, it's very important. It's going to help you. Now, we have matrix. When you multiply our matrix by our point, we are going to get the image. That means that you can transform a point by a given matrix onto an image. It's very important. You can transform a point by a given matrix onto an image. And we are going to take a look at some examples so that you understand what we are talking about. Now, let's assume that we are given a particular matrix. Let's say the matrix is 1, 2, we have 3, 2. And we are given the point. Let's say the point is 2, 3. The point P is 2, 3. And we are asked to find the image of P. We have to find the image of P. So, as I said earlier, when you multiply your matrix by your points, you are getting an image. That means you can transform the point by a given matrix onto an image. So now we are given A equals 1, 2, 3, 2. We are given the point 2, 3, and we have to find the image of P. So you know, we can say that with the solution, we can say, don't worry, we are given matrix P to be 1, 2, 3, 2. And we are given the point P. The point P is 2, 3. And we have to find the image. That is P prime. We have to find the image. So you can say that let P prime or the image be, we can use either XY, or it can be AB. Now, don't forget that we know that when you multiply a matrix by a point, you are getting an image. Now, our matrix is 1, 2, we have 3, 2. Let's multiply this by the point 2, 3. So this means that we are transforming. Take note, it's equal to the image, and we said that the image should be equal to XY. So we are now transforming the point 2, 3 under this matrix onto an image. Now this is a 2 by 2 matrix, and this is a column matrix. And so I know that you can multiply the 2 by 2 matrix by the column matrix. How do you multiply? You know that it's 1 times 2 plus 2 times 3. Then we have 3 times 2 plus 2 times 3. So 1 times 2 plus 2 times 3. We have 1 times 2 plus 2 times 3. Then we have 2 times 3. Then we have 3 times 2. Then we have 2 times 3. That is 2 times 3. This is equal to your XY. Don't forget that your XY is your image. That is what we said here. So to simplify this, 1 times 2 is 2. 2 plus 2 times 3 is 6, and this will give us 8. 3 times 2 is 6, and 6 plus 2 times 3 is 6. 6 plus 6 will give us 12, and this is equal to XY. That means that our P prime, that is the image, is 8, 12. Is 8, 12. Is 8, 12. So our P prime. So it means that transforming this matrix, transforming the point P 2, 3 under this matrix, you are getting 8, 12. So that is how we find the image when you are given your point in the matrix. That's how we find the image when you are given your point in the matrix. Now we are also going to look at how best we can find the point when we are given the image and that of the matrix. But that will be in our next episode. We also look at how when you are given points with their respective images, how you'll be able to find your matrix. And we'll be looking at that on our next episode. If you have not subscribed to the channel, I will advise that you subscribe to the channel so that you have an alert anytime we drop a presentation. So that will be all for now on this episode. But in our next episode, we will look at how to find the point when you are given the matrix and the image. And we also look at how you find the matrix when you are giving points with their respective images. But this is where we are ending on this particular episode. Thank you.